Saturn, mysterious, hauntingly beautiful. A swirling ball of gas embraced by heavenly rings that span over 150,000 miles. Circled by more than 40 moons in dizzying orbits. So distant, going there could only be a dream, until now. NASA and the European Space Agency are teaming up for the most ambitious unmanned space project ever launched. Across more than 2 billion miles, it will battle the bitter cold of space, thread the rings of Saturn, survive the heat of entry and brutal impact of landing, and beam pictures and data back from Titan, its largest moon. Nova follows this fantastic voyage to Saturn on a quest to solve some of the greatest mysteries of this alien world. Up next, Voyage to the Mystery Moon. Saturn, Lord of the Rings. Few sights in the solar system are more strikingly beautiful than this celestial sphere embraced by its majestic rings. This giant ball of gas, 750 times larger than Earth, visible as a golden star, has captivated our imagination since we first looked up at the night sky. But it wasn't until 1980 when we were able to get a close-up look at the sixth planet from the Sun. The Voyager deep space probes flew past Saturn and sent back tantalizing glimpses of this distant world. And Saturn's mysterious rings were seen closer than ever before.
Voyager got there and found this bewildering array of structure in the rings, and people set about trying to explain it right away.
What are the rings? How were they formed? When were they formed? And how long will they last? But the rings weren't the only feature Voyager explored. For the first time, detailed images of Saturn's moons were sent back, more than 40 in all, from dozens of minor moons to one nearly half the size of Earth. It was named after Saturn's mythological brothers, the giant Titans. Titan was unlike any moon that had ever been seen. It had clouds and an atmosphere 10 times denser than Earth's. Frustratingly, a thick layer of orange haze shrouded its surface.
We saw this fuzzy ball, and the immediate reaction is, what's below those clouds? You know, what are these clouds made of? What is hidden behind that layer?
Whatever was hidden, it had to be a solid body, or else its atmosphere would have long ago escaped into space. As Voyager confirmed, the atmosphere was nitrogen-rich and included organic molecules, perhaps resembling the atmosphere of the early Earth. Could Titan play a unique role in helping us understand the origin of life on Earth?
If you look at our solar system, there are only 4 bodies that have atmospheres and are actually solid bodies themselves: the Earth, Venus, Mars, and Titan. Venus is just so hot that one can melt lead on the surface. There are no organic molecules. Mars today is very cold, very dry, very thin, not a good place for organic molecules. And so we're left with Titan.
Voyager moved on, out towards Uranus, Neptune, and beyond. but Voyager's spectacular images of Saturn and its rings, and this enticing glimpse of Titan, left scientists wanting more.
The combination of the spectacular structure in the rings, the hazy atmosphere of Titan, just left every scientist with a great curiosity to explain those things that we had seen with the Voyager flybys. Immediately, there was a feeling that we had to return to Saturn and stay there for a longer time.
So in 1990, NASA and ESA, the European Space Agency, team up for an unprecedented collaboration. A new mission to Saturn with a landing on Titan. To get there, they need to build a spacecraft to travel more than 2 billion miles, battle the bitter cold of space, thread through the rings of Saturn, withstand the intense heat of entry and the brutal impact of landing, and ultimately beam back pictures and data. Their odds of success seem about as likely as throwing a basketball from NASA's launch site at Cape Canaveral, Florida, through a hoop in ESA's command center in Germany, without touching the rim. The spacecraft they designed to accomplish this mission, they named Cassini, after the 17th century astronomer who discovered gaps in Saturn's rings. Built by NASA's Jet Propulsion Laboratory, the Cassini Deep Space Probe carries an amazingly complex array of instruments. The eyes of Cassini are 2 sophisticated cameras.
One is a very long focal length, very high resolution, but you get little postage stamp-like coverage. And so you want to also carry a camera with a larger field of view, shorter focal length, that covers a greater amount of territory, so you can put your little postage stamp coverage in context, in geological context.
Cassini is also loaded with a powerful radar designed to punch through Titan's hazy atmosphere. And that's not all. Riding aboard Cassini on this 7-year mission is a small probe built by the European Space Agency. Named Huygens, after the astronomer who discovered Titan in 1655, this probe is designed to actually land on the moon's surface. It will see, sniff, touch, and listen to the mysterious moon, radioing back images and data to orbiting Cassini, under conditions that no one can precisely predict.
The atmosphere could have been thicker than we thought, or thinner than we thought, warmer or cooler. We had no idea what the surface was, so there was no guarantee that the probe would keep working after it hit the ground.
The engineers need to make sure that Huygens is tough enough for the job. Every aspect of the super-sensitive probe's design and construction must be put to the test. When the probe slams into Titan's atmosphere, it will produce temperatures of over 20,000 degrees Fahrenheit, more than twice the surface temperature of the sun. And it's this heat shield that is designed to withstand it. If the probe survives the heat of entry, successful landing will depend on the precise opening of 3 small parachutes. Packed for 7 years, these parachutes have to deploy, unfold, and inflate in sequence, or the mission will be lost. During the 2.5-hour descent, specially designed onboard cameras will act as the eyes of the probe. It is these cameras that will send home the first glimpse of Titan's surface. For Huygens imaging specialist Martin Tomasco, it is imperative that his cameras don't miss a thing.
What we're trying to get is kind of the skydiver's eye view, as if you were outside the probe and falling down through the atmosphere. We don't want to land near some interesting object like the Grand Canyon and not know it's there. To see through the haze has been notoriously difficult. We hope that our big advantage is that we'll fall through the haze and eventually we'll be under most of the haze and be able to see the surface that much more clearly.
After the descent through the orange shroud, the climax of the mission is touchdown on Titan's surface.
We set up a facility in the lab that would enable us to simulate what would happen when Huygens hit the surface of Titan.
This device, called a penetrometer, will measure the force of first contact.
You get a very different signal if you strike, for example, a sheet of solid ice, if you hit semi-compacted snow, if you struck a liquid, if you landed in a lake, for example. You know, we used to joke and say we would either thud, squelch, or splash down. And that really is quite a good description because it could have been any of those scenarios or a mix of them.
By 1997, the Cassini-Huygens spacecraft is built and assembled. But there is one major challenge. Together, their weight is massive.
The Cassini spacecraft is the largest interplanetary satellite that NASA has ever built and launched.
The big problem is how to get this 6-ton Leviathan into space. The most powerful rocket on Earth, the mighty Titan IV, is selected for launch, delivering over 3.4 million pounds of thrust. But even this will not be enough. For not only does Cassini have to break free from Earth's gravity, it has to travel almost 1 billion miles to Saturn on a small amount of fuel. The only way for Cassini to make the journey is to pick up additional energy from a flight path that takes advantage of an unusual convergence of the planets.
The energy that we needed to get out in the solar system, out to the planet Saturn, had to be supplemented by, partially provided by gravitational encounters with the planets. The important thing is to gather energy from the gravity of the planet you're flying by.
First, Cassini will be routed via the Earth's nearest neighbor, Venus. This planet's gravitational pull will accelerate Cassini, increasing its speed by over 8,000 miles per hour. But this will still not be enough. Cassini will need to return for a second boost from Venus. Then it's the Earth's turn, accelerating Cassini with a fling out toward its next rendezvous, Jupiter. Eventually, the spacecraft will clock up a speed of 50,000 miles per hour before reaching its final destination, Saturn. That's the theory. But will it work? October 15th, 1997. With the planets in perfect alignment, from NASA's launch site at Cape Canaveral in Florida, Cassini blasts into the night sky.
It sort of lit this cloud up like a Chinese lantern from within. It was quite spectacular. And you just think, wow, you know, it's out of our hands now.
The 7-year journey, covering 2.2 billion miles in all, begins. With Cassini-Huygens now en route to Saturn, scientists will soon have the opportunity to explore the mystery of Saturn's majestic rings and its enigmatic moon, Titan. Two years into its journey, the spacecraft loops around Venus a second time and swings back past the Earth. Here, the JPL scientists check out Cassini's high-power radar. It scans a huge swath of South America, and everything is in working order. The radar seems to be operating flawlessly. Next, they perform a simulation to test the radio link between Huygens and Cassini.
The Huygens probe itself doesn't have enough power, and it doesn't have a large enough dish to transmit its data, the scientific data that it collects on Titan, directly back to the Earth. So what will happen is that it uses the Cassini spacecraft as a data relay.
The test is to make sure that Cassini is receiving all the data from Huygens. But when the results come back, they are alarming.
We were expecting to receive all the simulated data. Unfortunately, we did not receive very many of those data. We lost, maybe 90% of the data, sometimes even all of the data.
If Cassini fails to receive the data from Huygens, then when the probe descends to Titan, there will be no results, no pictures, nothing. A crucial part of the mission will be lost. Huygens' European team calls a meeting to discuss the situation. As one of NASA's imaging specialists for Huygens, Martin Tomasco cannot believe what he is hearing.
They said, we've performed the test, and we didn't get any signal, but the test accomplished all of its objectives. And some of us were sitting around the table saying, what exactly are you trying to sell us? You know, you accomplished the objective of conducting the test, but you actually succeeded in proving the thing is not going to work.
6 months of painstaking detective work finally pinpoints the problem. When Huygens is descending to Titan, Cassini will be speeding away from it at 12,000 miles per hour. They will no longer be able to communicate on the same frequency.
It was enough to essentially put the link between the two out of alignment. It was as if Huygens was transmitting on radio 1 on one frequency, and Cassini was receiving on radio 2, a slightly different frequency. So this was potentially disastrous.
Retuning the receiver is impossible. Cassini is out in space over 300 million miles away.
There was no way we could repair. So we had to find a new mission scenario which would allow us to live with this problem, but still to recover the whole mission.
After months of research, they devise an ingenious plan. Although they can't retune Cassini's receiver, they can shift the signal it is picking up by using a basic principle known as the Doppler effect. If they can slow Cassini down, it will receive the radio waves that Huygens is sending at a lower frequency, solving the problem.
All in all, it took us 6 months to find a solution, but it took us 2 years to design all the detail of the solution and to test it. We are not going to lose any science, so it's a very successful recovery.
Both teams are now hopeful that Huygens has a good chance of sending back its precious data when it finally reaches Titan. By the year 2000, Cassini is now 1.5 billion miles out in space and arrives at Jupiter, the giant of the solar system. With a planet twice as massive as all the others combined, Cassini's cameras face their biggest test yet. Jupiter's majesty is revealed as never before. Its swirling gaseous atmosphere is seen with breathtaking clarity. But Cassini has to move on, across another 500 million miles of space, before it reaches its final destination. For imaging team leader Carolyn Porco, the Jupiter pictures are a triumph. But her true goal is the planet she has devoted her career and heart to studying, Saturn.
To know that we can know so much about our solar system and about our cosmos, for me, makes life meaningful. It's very much like being in love. It's very much that kind of a relationship where you want to know more and you want to be one with, you know, the person you're in love with or the topic that you're studying. It's kind of this, it's a connection. It's really a connection. And for me, it's like being allowed a glimpse of the miraculous.
Spring of 2004. Cassini is closing in on Saturn. But just before contact, mission planners calculate a precise course to send the spacecraft past Phoebe, Saturn's outermost moon. Until now, all that scientists had seen of Phoebe is this picture taken by Voyager 23 years ago. But this time, Phoebe is in the crosshairs of Cassini's powerful cameras. Picture after picture returns with astounding detail.
We buzzed Phoebe. Okay, we came within 2,000 kilometers of its surface. You could reach out and touch it is what it looked like. So it's very exciting. We saw features that were 30 meters across.
The images of Phoebe reveal an ancient surface pitted with craters created over billions of years. But Phoebe is just an appetizer, a taste of what is to come. June 2004. At the Jet Propulsion Laboratory in California, NASA's team has piloted the Cassini spacecraft across 2.2 billion miles of space and is still right on target, fast approaching one of our solar system's greatest enigmas, the rings of Saturn. Very little is known about them.
The questions that we scientists have about Saturn's rings are the questions that an ordinary person might be moved to ask when first seeing them. You know, what caused them? How did they get there? How long have they been around? How long are they going to last?
Answering these questions is one of Cassini's prime objectives. A good opportunity for close-range observation will come as Mission Control maneuvers Cassini into orbit around Saturn, because that means passing right through the rings. Voyager revealed that the rings are made up of rock-hard ice, ranging in size from a grain of sugar to a large house. The rings, just 300 feet thick and a vast 38,000 miles wide, are chaotic and dangerous.
All the ring particles, billions and billions of them, are in orbit around the planet Saturn, and they're moving at quite a clip, something like 10 kilometers per second, faster than a high-speed bullet. If you were in Saturn's rings, you would be in a mass of particles that were bumping into each other and rolling over each other. If you were a ring particle, you would get bombarded from one side and then from the other as one particle bounced off of another all around you.
Entering directly into the rings would be suicide. But NASA's JPL team has a plan. They calculate a course for the spacecraft through a 15,000-mile gap in Saturn's rings. Even so, with one small miscalculation, Cassini could be torn apart.
Even a very small particle could be the end of Cassini. If it hits a particle as small as a grain of rice, that would be enough, because of the high speed at which it's moving, to end the mission.
But particles from the rings are not the only danger that Cassini faces. It also has to slow down. That means firing up its main engine. Any malfunction, and Cassini will simply fly past Saturn, lost forever in the void of space.
That engine have not been used very frequently over a period of 7 years. It makes you nervous. You know, it's like you have a car, a brand new car that you put in the garage, and every once in a while you turn it on, and then you have an emergency and you get in the car and you turn it on, it better work.
June 30th, 2004. The press gathers at JPL for news of the most critical part of the 7-year trek across the solar system. The ring insertion maneuver begins at 7:36 p.m. First, Cassini rotates to use its giant antenna as a shield to protect it when it passes through the gap in the rings.
You can imagine how anxious some of us were, knowing that it all hinged on one 90-minute period where we would have to perfectly just slip into orbit.
All eyes are on a radio signal being sent by Cassini's auxiliary transmitter. If the signal continues, then flattens out at the bottom of the graph, they'll know that Cassini survived. A $3.2 billion mission and 14 years of work all hinge on this one moment.
The Doppler has flattened out.
Cassini has arrived. When the images return, Saturn is revealed as never before.
I just don't know what to say. I'm kind of speechless.
Oh, absolutely exciting. I mean, this is a culmination of 22 years of effort and just seeing the Lord of the Ring in its big glory. We are amazed about the detail that we are seeing and the sharpness in the rings. You wait years to have this kind of a moment.
These remarkable images begin to provide new clues to some of Saturn's oldest mysteries. What are the rings made of? And when were they formed? Since Voyager, scientists have known the rings are composed of rock-hard ice. Cassini is revealing far more about the composition of the ice.
The rings are made of ice, just like the stuff you've got in your ice cube trays. Almost 100% pure water ice with some small contaminants.
These contaminants, minute traces of dust that come from meteors, are the key to finding out the age of the rings. The basic principle is simple. The more contamination, the longer the rings have been bombarded, and the older they are.
The pollution is sort of like a clock because we're pouring material in on top of the rings, and it's dark, non-icy material. So the level of darkness in the rings tells us something about their age.
To discover the level of pollution in the rings, Cassini is equipped with a spectrometer that translates chemical composition into vivid color images. What they show is surprising.
The spectacular range of structure in the rings with reds and blue and aquas, that was something that was completely unpredictable.
The images show cleaner ice in shades of blue, the heavier contamination in red. So it appears that the inner rings are older, and that the outer rings have been made more recently.
It's definitely the case that there's a gradient in composition across the rings, so that the rings are less icy on the inside and more icy on the outside. As we go to the outside, the particles become younger and fresher.
These new spectrometer images seem to suggest an intriguing possibility: that perhaps Saturn's rings are still being formed. But beyond the riddle of the rings, another chapter in Cassini's voyage is about to begin. Its encounter with Titan, Saturn's mystery moon. Christmas Day, 2004. Mission Control navigates Cassini into a safe orbit around Saturn. Now they give the command to release the landing probe. They fire 3 explosive bolts, and Huygens pushes away from Cassini. In 1980, Voyager confirmed that Titan is one of only 4 bodies in the solar system that are solid and have a substantial atmosphere. The conditions that gave rise to life on Earth. Since then, what's beneath Titan's orange veil has captivated scientists' imaginations.
Whenever we humans think that we might be approaching something that is vaguely similar to Earth, we get very excited about it. The prospect of something familiar, but yet so distant and so strange, is a very exciting combination.
Billions of years ago on Earth, it's thought that simple molecules may have spontaneously combined to form more complex chemicals that became the building blocks of life. But Earth today is teeming with life. It has taken over the entire planet. This makes Earth problematic for studying the leap from chemistry to life.
It's very difficult to use the Earth as a laboratory for understanding how life began. Life eats all of the organic molecules that are present on the Earth today. If we go to the laboratory and try to simulate how life began, we have limits on time and space. A laboratory experiment might be this big. A laboratory investigator might work for 2 or 4 or 10 years, perhaps, no more than that. We really need a place where organic evolution is happening on a planetary scale over billions of years, but is not being ruined by the presence of life.
For years, scientists have been looking for a place that has a similar primordial chemistry to early Earth. Could Titan be that place? Based on data from the Voyager mission, scientists know the atmosphere of Titan contains nitrogen and methane made of carbon and hydrogen.
It's dominated by nitrogen, but it has methane and a whole range of hydrocarbon gases, gases made of carbon and hydrogen.
Scientists also know of one other ingredient that's crucial for making the leap from chemistry to life.
If we were to apply what is the essential ingredient of all life, liquid water, then we may well make some amino acids, which are the building blocks of life.
But how could liquid water exist on Titan with a surface that's nearly 300 degrees below zero? Control of Huygens is based at the European Space Agency Command Center in Darmstadt, Germany. Finally, the team is about to find out what lies hidden beneath the orange veil. On January 14th, 2005, 150 miles above Titan, Huygens slams into Titan's atmosphere. The time has come to witness Huygens' historic descent to Titan's surface.
The emotion in that control room, I mean, it was absolutely tangible.
But the scientists will have to be patient. It's still a long wait before any data is received back at Mission Control.
The fact that all the data was transmitted to Cassini, Cassini would then store the data and only some hours later send it back to Earth, meant that there was a delay time of several hours. So it was sort of unreal, knowing that things were happening. We didn't know if they were good things or bad things. They were happening, but we knew nothing about it.
Now operating on automatic, one minor malfunction can terminate the whole operation.
We have to have a heat shield that works and protects the probe from burning up during the entry. We have a series of explosive bolts that has to fire to release the heat shield and deploy the parachutes. They all had to work perfectly. If you make a mistake there, you lose the rest of the mission.
Everything has to be relayed from Huygens to Cassini, then back to Earth. So they are not expecting to receive any news of Huygens' fate for hours. But then, they get a surprise. They pick up a signal, not from the orbiting mothership, but direct from Huygens itself.
A few minutes ago, we have received confirmation of the carrier signal from Huygens.
It tells us that the probe is alive. The entry has been successful. We are on the parachute, and the probe is transmitting.
In Green Bank, West Virginia, the giant 360-foot dish of the Robert C. Byrd Radio Telescope is pointing directly at Titan. It is listening for even the faintest of signals.
We were kind of eavesdropping on the conversation between Huygens and Cassini. So the strength of this signal which we deal with is practically the same as the strength of this signal from mobile phone, but located not in your pocket or my pocket or somewhere nearby, but at the distance of 1 billion kilometers on Titan.
Receiving a radio signal from Huygens is the first indication that all is going according to plan.
This is absolutely fantastic news. It's like hearing the ringing tone on the phone. It tells us the phone is working. There's no information on it yet, but it's absolutely fantastic.
The radio signal from Huygens is too weak to relay any scientific data. For that, Mission Control will need to wait for Cassini.
We were told to expect the data at 15:24 Central European time in the afternoon. And I remember 15:24 came and went, and we were looking at the screens. We knew where the numbers should have appeared, and absolutely nothing.
And we're thinking, how is it possible that everything could have worked well on Huygens and we wouldn't get data? And we say, oh yes, it could have worked perfectly on the probe, but if the orbiter didn't receive it, we could still lose the whole thing.
You know, the minutes ticked by, it got quieter and quieter. We were looking at each other.
And 2 minutes goes by, and 4 minutes goes by, and 6 minutes goes by, and there's still nothing. And we're all just shaking our heads, and there's just gloom, absolute gloom over the whole audience.
15:30, so this was 6 minutes after we were led to believe the data would come through. I can remember looking at one particular screen, and where there was a large gap before, suddenly a whole column of green figures appeared. And this was the first science data from Huygens.
Finally, the Cassini mothership is sending all of Huygens' scientific data back to Earth. Although the probe actually landed on Titan's surface some hours ago, only now can the scientists begin their own descent onto Saturn's mysterious moon. But for Martin Tomasco, the first images he receives are murky.
We saw a lot of inside of the milk bottle pictures in the beginning. You know, it's just all washed out. Somewhere between 50 and 70 kilometers, we thought we'd come out through the bottom of the haze, have clear views of the surface. Well, that was not the case.
If the haze continues all the way to the ground, Huygens will fail to obtain crucial photographic data.
We finally got close enough to the ground to see the ground through the haze at 30 kilometers altitude only, and that was beautiful. And that was the first stuff we saw.
After decades of wondering what the surface of Titan looks like, scientists now get their first glimpse beneath the haze and discover a surprisingly Earth-like geography.
Sort of looked up, and there was, you know, this projection screen, and the first thing you see is these river valleys everywhere, and you think, wow.
All of a sudden, you could see these drainage channels. It seemed to come together over the highlands, over the bright material, and when you got to the dark material, there was this low region that looked like a flat lake bed. You know, after all this, you go down through the haze, and there it is, this dried riverbank that looks like in the backyard in Arizona somewhere.
Having survived the descent unscathed, the most anticipated moment in the entire mission is the touchdown on Titan. Upon contact, Huygens' penetrometer reveals the nature of the surface at the landing site.
We're sitting on icy grains, which have the consistency of sand. It's sort of gravel, fine gravel you might see on a river shore or on a dried up lake bed.
When the probe, hot from the friction of entry, contacts the icy surface, the surface melts, and Huygens' chemical sniffer detects a curious spike.
The amount of methane that the chemical sniffer was detecting jumped very quickly, and it jumped up in such a way that there must have been, underneath this warm probe, a pool of liquid methane.
From over 1 billion miles away, Huygens' landing confirms what scientists had suspected, that not only its atmosphere, but also the surface of Titan contains the organic compound methane. It has been nearly 25 years since Voyager took this first hazy image. Now, with Huygens, comes this first close-up image from the surface of Titan.
Can you
show the first picture, crop 448, on the screen, please, and we will see Titan unveiled as we haven't seen it before.
Huygens' camera reveals its landing site as a dry riverbed with rounded pebbles made of ice beneath an orange sky.
If that image alone was the only piece of data produced by the Huygens mission, I would say that it was worthwhile.
But that image is not alone. Others reveal networks of rivers, hills and valleys, and a surface made of damp sand, a mixture of icy pebbles and liquid methane. Huygens, mankind's furthest outpost in the solar system, transmits data and images for 180 minutes, then dies. But Cassini, its mothership, lives on. From its orbit around Saturn, it peers down as it passes over the mystery moon and continues to reveal a whole new picture of Titan.
Cassini was definitely not just about getting Huygens to Titan. Cassini was about exploring Titan. The orbiter has been unveiling Titan in its own very special way.
Using remote sensing, infrared and radar imaging, Cassini pierces through Titan's thick haze and reveals that Titan's surface has many familiar Earth-like features.
We're seeing river channels, we're seeing erosion, but whereas on Earth we're talking about rocks and liquid water, on Titan it's ice and liquid methane.
This is a world suffused with methane, raining down from the atmosphere, carving out hills and valleys, eroding ice rocks, and finally sinking into the sandy surface. In addition to erosion from methane rivers, Cassini reveals that Titan's surface appears to have also been modeled by lava flows. But this is lava as never before seen.
We saw some structures on the surface of Titan that look very curious. They look like volcanoes, but these are very different than the kinds of volcanoes that you would expect to see on Earth. These are what we call cryovolcanoes.
Volcanoes on Earth erupt molten rock. But the cryovolcanoes on Titan's frozen world erupt something altogether different.
The working fluid for a volcano on Titan is water, but it's water mixed with ammonia. And the result of that is it lowers the freezing temperature of water from 0 degrees C down to as low as minus 100 degrees C. If you could climb up to the summit of a volcano like this and look down in its caldera, you would see a very sticky, viscous fluid that's literally oozing out of the ground and flowing down the flanks of this volcano, much like a very, very fast glacier.
Methane in its rivers, nitrogen in its atmosphere, and now the presence of this bizarre form of water. Huygens and Cassini have made a remarkable discovery. Titan may indeed have all the key ingredients to form the basic building blocks of life.
These things all operate on Titan under exotic conditions in much the way that they operate on the Earth, but there's no life on Titan. And so it's telling us that the basic conditions for a world where life can begin could occur in many places, but if temperatures are too cold, the whole process is going to be slowed down. And so we're looking at an Earth-like world where the chemistry has just not gotten to the point yet.
In these oozing volcanoes, it could be that organic molecules are too frozen to combine and form the more complex molecules of life. But beneath the surface, where it's warmer, There could be living microbes feeding on organic molecules and producing some of the methane in Titan's atmosphere. Cassini will orbit Saturn for years to come, searching for more clues to the oldest mysteries of the Lord of the Rings, the age of the enigmatic rings, and how they were formed. And the spacecraft will continue to fly by Saturn's many moons. Recently, Cassini revealed that Saturn's fourth largest moon, Enceladus, is erupting plumes of icy crystals. This suggests that pockets of water may be just beneath the moon's surface. Adding Enceladus to the short list of places in our solar system that are potentially suitable for life. And Cassini will continue to visit Saturn's largest moon, a world both alien and Earth-like. A place that still holds many secrets. Titan, the mystery moon of Saturn.